This video is on the second derivative and concave up and concave down. When we've done the derivative once and we get f dash x, if we do the second derivative, it just means doing the derivative again. And we'll have f dash dash x, or we can write it d squared y over dx squared. What this does is it measures the rate of change of the gradient. So a really quick example, if f of x equals x cubed plus 3x, find the second derivative at 2. Really simple with this means we have to find the derivative first, so f dash x, which would be 3x squared plus 3, and then find the double derivative, we do the derivative of that. So the derivative of 3x squared plus 3 would be 6x. And then we want to find the double derivative when x equals 2, so we just sub 2 in and we'll get 12. Next part, concave up and concave down. A function is concave up where the second derivative is greater than 0, and a function is concave down where the second derivative is less than 0. Using the words increasing, decreasing, concave up and concave down, describe the following sections of the graph: A to B, C to E, and F to G. So part A. So from A to B, we can see that it is going downwards, which means it is decreasing. Now, because it is going downwards and going into a curve at the bottom here, like this, actually means it is going to be concave up. And then from C to E, so from here to here, it's increasing first and then decreasing, so we can't describe it just using one word, but we can say that it is concave down. Then from F to G, you can see it is going up there, it's just going up only, so we know it is increasing. And once again, it is concave up because it's coming out of a curve and a minimum. Example 2. Find the values of x for which the function f of x equals x to the power of 4 plus 2x cubed minus 36x squared plus 5x minus 4 is concave down. So when we are looking whether things are concave up or concave down, which is their concavity, that is a hint that generally we're going to be finding the second derivative, so let's do that first. Our first derivative would be 4x cubed plus 6x squared minus 72x plus 5. And then our second derivative will be 12x squared plus 12x minus 72. Now for here, if it's concave down, we are wanting when the second derivative is less than 0. So what we're going to do now is solve that equation. So we're going to have 12x squared plus 12x minus 72, and we want to know when that is less than 0. And then we just solve this, you'll see it's a quadratic. First thing, I'm just going to divide everything by 12 to make it a bit simpler. So we'll have x squared plus x minus 6. We want to know when that is less than 0, and then we can factorise that, and we will end up with x plus 3 and x minus 2 is less than 0, which means our x can be between -3 and +2. Now, to do this and work out our interval, or where, for what values the function is concave down, we know it's going to be an interval. We can just quickly sketch it. Okay, so if we were to sketch this graph, it looks something like this. We know this point here would be -3, this is 2, and we want to know when this graph is less than 0, so it's going to be everything below the graph, which is going to be between -3 and 2. So our solution will be that x has to be greater than -3 and less than 2. And that is the end of this video.